Hi guys, welcome to this video on corresponding parts of congruent triangles. So we are learning to prove that two parts of a triangle are congruent using CPCTC. Otherwise, it's going to be very difficult for us to construct proofs that two parts are congruent in triangles. And you're going to know you're successful when you can actually make the two-column proof to prove that two segments or angles are congruent. So, we had some practice in proving two triangles are congruent in the last section using the four congruent shortcuts, SSS, SAS, ASA, and AAS. When two triangles are congruent, it means they are the same, so we further clarified that to mean that all angles of the triangle are the same and all sides of the triangles are the same. So this is formalized in a theorem called the corresponding parts of congruent triangles are congruent theorem, more commonly known as CPCTC. If two triangles are congruent by one of the four congruence postulates, then all of the corresponding angles and sides of those triangles must also be congruent. So, if ABC is congruent to DEF, then every pair of sides and angles of triangle ABC and triangle DEF are also congruent. So, in the diagram here, all of those are congruent if you use a congruence shortcut to prove that those two triangles are congruent. So what is it for? CPCTC is used as an additional reasoning step for us to make statements in two-column proofs that a pair of sides or a pair of angles is congruent within two triangles. So once we have proven that the two triangles are congruent with one of our shortcuts, SSS, SAS, ASA, or AAS, we can use CPCTC to say that one of the pairs of sides or angles is also congruent. So basically, it's just an extra step. So once we've proven that triangle 1 is congruent to triangle 2 for whatever reason, we can then say that the missing piece, in this case side A and side D, are congruent using CPCTC. So it's just adding an extra line to our proofs basically. So here's an example. Prove that AD is congruent to BC. Alright, so my end goal is to prove that, okay? I start every proof by writing out what it is I am being asked to prove. So AD is congruent to BC. So let's start with our given information. We know that angle B and angle A are marked as congruent. So let's go ahead and write that out. Angle B is congruent to angle A. And that's given. Okay, so from now on for given, I'm just going to draw a G. So I can then also say that BM and AM, side BM, excuse me, and side AM are also congruent. So side BM is congruent to side AM, and that is also given. Now I need to look for a third piece of information. I don't really know anything about sides AD, BC, or CM and MD, but I can definitely say that angle 1 is congruent to angle 2. And they're opposite of each other, so that's basically the vertical angles theorem. So I now have used an angle, and the side that I used, because I always have to use at least one side, was between the two. So I can now say that triangle AMD is congruent to triangle CMB. And I proved it using angle, side, angle. So here are the other congruent angles. Angle, side, angle, the sides between them. So then I can say that this side, AD, is congruent to this side, BC, by using that new reasoning CPCTC. So, as you can see, we just added an extra line to our proofs. So usually we would have stopped here before, right after this triangle congruence statement. But now we're adding that extra step of, okay, I want to prove another pair of sides or angles is congruent, and that's by CPCTC. All right, let's do another. Oh boy, prove that AE. So we're going to prove that AE is congruent to BD. So we're proving this side here is congruent to this side here. So it looks like we're using some triangles here. So you know what? I do notice immediately, this is what they're asking me to prove. So that is what I'm going to put at the bottom of my proof, because I know that eventually my final statement has to be the proof of that. So BD. All right, so let's tackle some given information here. I do know that angle A is congruent to angle B. It is marked as such. So that is some given information. So I'm just going to use G for given. I also know that angle D here, angle ADB, is congruent to angle BEA. And again, that's also given information, so I'm just going to write G for that. Okay, so now I need to look for, so I've got two angles here. I've got an angle and an angle of given information. So I know that all four of my proofs have to use at least one side. So let's look for some side that we can say is congruent. I can't say anything about EB and DA. I can't say anything about AE and BD. I'm going to change my bottom here really quick. I made a mistake. Because that's what I'm trying to prove. So I can't use this pair of sides in the proof to prove these are congruent. But you know what? I do notice that they share this side in common right here. So I can definitely make a side statement of saying that AB is congruent to AB. And that is reflexive. So that's a property we've seen a couple times. When a pair of sides overlap each other, it's called reflexive because they are guaranteed to be congruent to each other. So now I have the two triangles are congruent to each other. So I can say that triangle, we're going to go triangle ABE. Fix my E here really quick. Is congruent to triangle BDA. And I proved it using angle, angle, and then the side is not included. So we used angle, angle, oh, too big. Angle, angle, side. So then I can conclude that the two additional sides, AE here and BD, are congruent using CPCTC. And that's how CPCTC works, guys. So that's it for this section. And I will catch you in the next video on similarity.